Hi, everyone. Today we're going to be talking about section 2.6. Section 2.6 is called translations or transformations. So I'm going to go over this PowerPoint and hopefully it will be helpful because it has a lot of color and hopefully the translations will make sense. So let's go ahead and get started. We will be looking at functions from our library of functions and seeing how various modifications to the functions transform them. Okay, let's go ahead and talk about vertical translations first. Okay, vertical translations are the translations that are going to move in a specific form. For example, I'm giving you the parabola graph, okay, the graph of f of x is equal to x squared. And the way you're going to see it on your textbook or the homework on WebAssign, it's going to be, what would it look like, f of x plus 1, if you had to graph this? This would mean taking all of the function values and adding 1 to them. Okay, so I don't know if you guys can see, but f of x is equal to x squared. So in reality, this represents x squared plus 1. Okay, so as you can see on the graph, I'm kind of giving you the shift. This is what we call a vertical translation. You have the same exact function, f of x, but then you're adding a 1 to each y component, okay? So then if this is a 0, 0, and the y is shifted by 1 unit, then it will be 0 and 1. If x is 1 and my y is 1, but I'm going to add 1 more unit to the y, then it will be 1 and 2, etc. Okay, let's go ahead and try another example. What would f of x minus 3 look like? This would mean taking all of the function values and then subtracting a 3 from them. Okay, so you have the same graph, the blue parabola. You have the original one, but now you're going to be taking away 3 from each y component. Okay, that means that you're going to be moving it down 3. That will be the green graphs that you see on the screen. Okay, as you can see, a number added or subtracted from a function will cause a vertical shift or a translation in the function. A vertical translation. Here's another example with the V shape. Remember that the V shape belongs to the absolute value. Okay, so here we go with first example. What would it be if I add 2? So f of x plus 2 look like. So I'm going to take my same graph and I'm going to be adding 2 to the y component. This represents y. So every y, I'm going to add a 2. So if this is a 1 here, my 1 right here, and I'm going to be adding a 2, then this has to be at a 3. And so this is a 1, it also has to be at a 3. If this is 0 right here, but I'm going to be adding 2, then it has to be here. Okay, I'm going to be adding those values, and you can see that I get the red graph. It's one more example. What would f of x minus 4 look like? Now, instead of adding, we're going to be taking away 4 from the y value. So I still have the original graph. The original graph, it's the blue graph. From every y value, I'm going to be taking away 4. Okay. For example, if I look at this one here, this point, this is 4. If I take away 4, then that will be 0. So this point right here, it's going to go all the way to here. If I look at this one, this y value, it's a 3, but I'm going to be taking away 4. So if I take away 4, then that will be at negative 1. Here's 2. My y value, it's 2. If I take away 4, then it will be a negative 2, etc. If I take away 4 from 0, then it will be at negative 4. And you keep on doing that for every y value. So you can see that that will give you the green graph. So the graph f of x plus k, where k is any real number, is the graph of the original function, f of x, but vertically shifted by k, meaning it's going to move up or down depending on if it's positive or negative. So if k is positive, it will shift up. If k is negative, it's going to do a shift down. And you can see it here. We shifted up 2 units up, 2 units up from the original graph. There's a -4. We shifted down 4 units down from the original graph. Let me go ahead and move on to horizontal translations. Horizontal translations are the translations where we move to the right or to the left. Okay. That's what we call horizontal translations. Here's an example. This is the graph of the parabola again. Okay, f of x is equal to x squared. Now, the way we tell you that this is a horizontal translation is by the given notation. What would f of parentheses x plus 2 look like? We're no longer adding the 2 to the y value. Now we're adding the 2 inside. So in reality, we're adding the 2 to the x component, not to the y anymore. Okay, this would mean taking all of the x values and adding 2. Okay, so in this particular case, what I'm going to be doing is I'm going to be moving it to the left 2 units. Okay, so this is what I'm doing. I get the right here, and I am going to be adding 2 units. But if I add 2 units, so let's go ahead and think 2 units to the x. So in this case, my x is this one. My x happens to be -2. So if I add -2 plus 2, then that will be a 0. That's why this is 0. This is a -1. If I add -1 plus 2, then that will give me a 1. And you can see this value. When x is 0, okay, if I add plus 2, then I should be able to get plus 2 squared, which that will give me that 4. Okay, here we go with another example. What would f of x minus 1 look like? This would mean taking all of the x values and subtracting that 1 from them before putting them into the function. So now in this particular case, it says take away 1. So we're going to take away 1 from every x value, and then we're going to be squaring them. Okay, so let's go ahead and see what will happen when I take away, let me see. Well, you can try any x, but you will see that it will be the green color graph, okay? And you can see the reason why we're going to be taking away 1. So then when, for example, like if the x is at -2 from the blue graph, that's the original one, -2 minus 1, that will be a -3 squared, that will be a 9, but 9 is not in here, so you wouldn't be able to see that it's -2 or 9. But when x is -1 and you plug it in here, that will be a -1 minus 1. That will be a -2. -2 squared, that will be a 4. So this is -1, and that will be a 4. Okay, when I input a 0, okay, 0 minus 1, that will be a -1, but -1 squared, that will be a +1. And then can you see right here that it's always the opposite sign? When I input the 1 in here, it will give me a 0, which is the point right here. Well, etc. As you can see, a number added or subtracted from the x will cause a horizontal shift or translation in the function, but opposite way of the sign of the number. Okay, so you started with the blue graph. If they give you plus inside, you're going to shift left 2 units. So we shifted left 2 units from the original. If they give you a subtraction, you're going to move to the right. So it's the opposite sign. That's what it says right here, opposite way. So +1, we shifted to the right 1 unit. Horizontal translations. Okay, so let's go ahead and do another horizontal translation with the cubic function. Above is the graph of the cubic function, f of x is equal to x to the third. What would f of x plus 1 look like? Okay, so this is the original one, okay? But I'm going to be adding 1 to every x input, every x. So in this case, if my x is -1, okay, what happens when I input that -1 in here? So it will be -1 plus 1. It will be a 0, and then 0 raised to the third power. Okay. That will still be a 0, and you can see that it kind of shifted. So it shifted to the left 1 unit. Okay. If we were to select the 0 on the blue curve and I plug it in, 0 plus 1 will give me a 1, and 1 to the third power will still be a 1, and that will generate the red color graph. Let's do one more example. What would f of x minus 3 look like? In this case, I'm going to be subtracting 3 from every x from the original graph. The original graph, it's the blue graph. So you got to consider that one. So I have a -1 and a 1. It's this point right here. I'm going to plug in this -1 in here, and that will be -1 minus 3. That will be a -4. But -4 to the third power, okay, that will be a -64. When I plug in the 0, 0 minus 3, that will be a -3. -3 to the third power will give me a -27, and so forth. And you can see it, it's right here. It's the green color graph, and it's moving. Okay, I started with -1 and then with 0, but you can try 1, you can try 2, you can try 3. But once again, you know that this is the opposite, so you're going to be shifting to the right 3 units. I will show you later on in class how to apply the translations. Hopefully you're writing detailed notes about this PowerPoint. So the graph f of x minus h, where h is any real number, is the graph of f of x, but horizontally shifted by h. Notice negative. If you set the stuff in the parentheses equal to 0, and if you solve, it will tell you how to shift along the x-axis. Okay, very quickly. So they say if you set the stuff inside the parentheses, the stuff is x plus 1. So if you put it equal to 0, that, and you solve for x, that's going to give you a -1. So you know that it's going to be shifted to the left by 1. If you have x minus 3 and you put it equal to 0, when you solve for x, x is going to be equal to 3. And so you know that it's going to be shifted to the right by 3 units. Okay, so the graph of x minus h, where h is any real number, is the graph of f of x, but horizontally shifted by h. Notice the negative. Okay, so once again, it's the same thing that I had read, and I just gave you the example just so you know that it has been shifted. And you can see the shift right there highlighted in yellow. Okay, we could have a function that is transformed or translated in a combination of both vertically and horizontally. Now, you don't have to necessarily remember the exact perfect name, the vertically translation or the horizontally translation. I will take upward, downward, or right or left. Okay. So in this particular case, the graph that you see, the blue graph, belongs to the radical. Okay. By the way, we went over the radical in class, okay? And most of the graphs that you have seen, we went over all of those graphs in class as well. Okay, so above is the graph of the radical. Now, what I want to do is a combination. I would like to do the graph of f of x is equal to the radical x plus 2 inside the radical, then plus 3. Okay, notice the plus 3, it's outside of the radical. This plus 3 will be your shift upward, which is your vertical translation. The inside, x plus 2, it's part of your variable x. So this is the shift that it's going to be moved to the right or to the left. In this case, it's going to be to the left 2 units, or horizontally 2 units to the left, okay? See, left 2 units, and then up 3 units. Sorry, I went too quickly, I think. You gotta be able to know how to read it. In fact, on your test, I usually tell you, go ahead and describe the translation. So you're gonna tell me we have a shift left 2 units and then a shift up 3 units. Okay, let me go ahead and move on to stretching and compressing. If we multiply a function by a non-zero real number, it has the effect of either stretching or compressing the function because it causes the function value, the y value, to be multiplied by that number. Let's try some functions from our library of functions, multiply by non-zero real numbers to see these examples. Okay, we're going to start with the graph of f of x is equal to the absolute value of x. And what we want is, we want to know what happens when you multiply by a whole number 2, by a number 2. What happens when I multiply the 2 by the y? So this absolute value of x is going to be multiplied by 2. If it gets multiplied by 2, notice that your y value is going to be changing. Okay, so you're going to see that you see the red color graph. I kind of want to show you why, because when x is -1, my y value is 1. Why? The y value is 1, but I'm going to be multiplying that y value by this 2 on the outside. So that will become a 2 right here. When x is 1, okay, and if I multiply that 1 by 2, I get that 2. And then you can see the red color graph. Notice for any x on the graph, the new red graph has a y value that is 2 times as much as the original blue graph's y value. Okay, what will happen if we multiply by 4? 4 times f of x. Well, you're going to be multiplying it by 4. So if this one was a 2, most likely this one right here is going to become a 4. And most likely this one will also become another 4 here. And that one will still be a 0. And you can see the green graph. Okay, I hope you guys can see what's happening. We started with the blue graph, and then it becomes the red graph, and then the green graph. So notice for any x on the graph, the new green graph has a y value that is 4 times as much as the original blue graph's y value. So the graph of a times f of x, a, it represents any real number greater than 1, okay? So for example, in this case, I gave you 2 examples where the a is greater than 1. So in this case, we said a is equal to 2 or 4. But if it's greater than 1, okay, then it will be vertically stretched, okay? You're stretching it vertically. Or you can also say dilated by a factor of a. What if the value of a was positive, but what is the value of a is less than 1, so not greater than 1? So what happens when it's a fraction? Okay, for example, what would 1/2 f of x look like? Okay, so remember, I'm going to be looking at the y values. So right here on my blue graph, I have a 1. And if I'm going to be multiplying that 1 by this 1/2, I hope you can see that I'm going to be cutting it down right here. So it's going to become a 1/2. The same thing on the other side. Whatever input you decide, look, if I input the 2 and I multiply that 2 by 1/2, then half of 2 will become a 1. So it's going to be doing this shift. Notice for any x on the graph, the new red graph has a y value that is 1/2 as much as the original blue graph's y value. Okay, what will 1/4 f of x look like? So what happens when we multiply by 1/4? Yeah, I hope you guys can see that the original graph is the blue one. If this is a 1 and I multiply by 1/4, then it's going to be shorter right here. It's smaller, 1/4. And this one's going to be 1/2, like about here. So then you can see the green graph. The green graph gives you what I asked you for. Notice for any x on the graph, the new green graph has a y value that is 1/4 as much as the original blue graph's y value. So the graph where a is between 0 and 1 is the graph of f of x, but vertically compressed, okay, or dilated by a factor of a. What if the value of a was negative? What happens when we have a negative value right in front of it? So we have the original absolute value of x as a graph, but now I want to know what happens if I have a negative right in front of the original graph. So if I have a negative, my y values are going to become negative. So in this case, if this is a 1, my y value is going to become a -1. If this y value is a 2, my y value is going to become a -2. If this is a 1, y value is a 1, my y value is going to become a -1. So it will be a reflection on the x-axis. This is what we call the reflection. Notice any x on the new red graph has a y value that is negative of the original blue graph's y value. So the graph of a negative f of x is what we call a reflection about the x-axis of the graph of f of x. The new graph is obtained by flipping or reflecting the function over the x-axis. Okay, there's your x-axis highlighted in dashed green. And so you just reflect it downward. There's one last transformation we want to look at. Above it's the graph of f of x is equal to x to the third power, which is the cubic function. What I want is what happens when we have a negative in the inside of the variable, not on the outside. Okay, so very quickly, I'm gonna go back. This negative, it's on the outside of the original function. In this case, I want to know what happens when the negative is inside the actual function, okay? This means we're going to take the negative of x before putting in the function. So my x's are going to become the, okay, so this is a -1, and if I plug it in here, that's going to be a -1 times a -1 that will become a +1, 1 to the third power. So this one will become a 1 here. Not down, but here. If I input a 0, well, -0, that will be 0 to the third power is still 0. But if I input a 1, that will be a -1, because this is going to make it change. Okay, you can see that it's the red graph. Notice any x on the new red graph has an x value that is the negative of the original blue graph's x value. So the graph of f of -x is a reflection about the y-axis of the graph of f of x. The new graph is obtained by flipping or reflecting the function over the y-axis, okay? So in this particular case, the reflection is about your y-axis, and you can see that in this case, it's the green line happens to be your y-axis. Okay, here's a summary of what we learned. If a is positive, I'm sorry, if a is greater than 1, then we will have a vertical dilatation or stretch by a factor of a. If a is between 0 and 1, then vertical dilatation or compression by a factor of a. If a is less than 0, then the reflection about the x-axis, because it's negative, as well as being dilated by a factor of a. If we have a negative x, reflection, it's about the y-axis. That will be your vertical translation. If you don't like the word vertical translation, you can also use the up and down translation. That will be a horizontal translation or a right and left translation. Okay, here's an example of one of them. Okay, using translations. We have talked about the rational function 1 over x. Okay, so this is the original. In fact, we went over this graph in class. This is the original graph, 1 over x, but we gotta apply certain things. We have this negative. This negative means it's a reflection. So I'm gonna reflect this graph over the x-axis. This curve, it's going to be down here now when I reflect it. And this curve is going to be up here when I reflect it. So that's what the negative is going to do. Now, this is a part of the x. So this one says it will be shifted to the right by 2. Or it's a horizontal shift by 2 units. And then this will be upward by 1. Okay. So let me go ahead and describe what I'm doing. That's a reflection about your x-axis. That's the first thing that you want to do. You want to look at the sign first. Okay, that one moves up. So we're going to move it up by 1 unit. Last, this one's going to move to the right. Your final answer happens to be the brown color graph. You will have to delete all of the other colors to submit the answer. Okay, so then that will be your answer. That's the final answer. Okay. And this is how you're going to do it on the test. If I ask you, you gotta tell me the reflection. So you can tell me it reflects about the x-axis, it moves to the right by 2 units, it moves up by 1 unit, and then you're actually going to give me the actual graph. Okay, so this is basically what we went over. Okay, and don't worry about the rest of it here. Okay, we are done with section 2.6. Now you're ready to try some examples on your own, and then I will do some examples in class. Have a great day. Bye.